Assalamu alaikum and welcome back to Learn with Mafaza. In this video, we will explore how to work with dates and times using Pandas. Dates and times are a crucial part of data analysis, especially in areas like sales trends, customer behavior, or project tracking. We will cover how to convert data into datetime format, extract specific components like year, month, and time, and even calculate date differences. Let's get started. Let's take a look at the data types in our data frame using the .dtypes attributes. Here is the results. This shows the data type of each column in the data frame. Let's focus on two common types, object and float. Columns like customer ID, product, category, order date, and region are shown as object. In Pandas, object typically means text or string data. For example, customer ID contains alphanumeric values like CUS001. And product and category contains the names of products or their categories. Order date, while it's look like a date, it's stored as a string because it hasn't been converted to a proper datetime format yet. Object data types are used for columns that don't involve numeric calculations but are great for categorical or descriptive information. And float data type. Columns like quantity, price, and total are shown as float 64. The float data type represents decimal numbers. For example, quantity might have fractional values like 2.5, 10.2 something, which could indicate half-sized item. And price contains the cost of each product, which often includes decimal for cents. And total stores the total value calculated from quantity and price. Using float 64 allows us to perform numeric operations like summing, averaging, or other calculations with high precision. By understanding these data types, you can better manipulate your data. For instance, you can convert order date from object to a datetime type for easier date analysis. Similarly, numeric columns like price and total are ready for aggregation and mathematical operations. Let's take a look at some other common data types you may encounter apart from object and float 64. First one is INT64. The INT64 data type represents integer numbers. These are whole numbers without decimals, such as 500 or -20, something like that. And you will typically find this type in columns like maybe in quantity or order ID, like that, if they are purely numeric. And integers are useful for counting or when the data doesn't require decimal precisions. The next one is Boolean. The bool data type stores true or false values. This is commonly used for columns that represent binary states, such as whether a product is in the stock or whether a customer is active. Likewise, so Boolean columns are perfect for filtering or logical operations. The next one is datetime 64. The datetime 64 data type represents date and time information. It's essential for working with time-based data such as order dates or timestamps. And you can see the examples. And with datetime 64, you can extract components like year, month, or day and calculate date differences. Next one is category. The category data type is used for categorical data which contains a limited number of unique values. For example, include columns like region, north, south, east, or west, or product categories. Using category reduces memory usage, making your data frame more efficient. And it's ideal for data with repeated text values. The next one is string. String introduced in recent versions of Pandas, the string data type is specially for text data as opposed to the general purpose object type. It provides more string specific methods for manipulation and is recommended for handling text in new projects. And then float 32 and int 32, less commons. These are smaller version of float 64 and int 64 and use less memory. They are useful for large data set where reducing memory usage is critical. We have seen the data types of each column in our data frame. So our order date is in object format. So to begin, we need to ensure our date columns are in the correct form. Pandas provide the pd.to_datetime function which converts string into datetime objects. Let's see with a practical example. In our data frame, we have to convert order date into datetime format. So df order date equal pd dot to datetime df order date datetime. So order date. So now the order date column is stored as a datetime object. This format allows us to perform advanced operations like extracting components or calculating time differences. Now let's learn how to extract specific components from a date column in Pandas. This is a useful technique for analyzing trends by year, month, or even the day of the week. Here's the code. df year, extract the year from the order date column. And df month gets the month represented as a number from 1 to 12. And df day retrieves the specific day of the month. df weekday returns the name of the day like Monday, Tuesday, Wednesday, likewise. Once we run this code, Pandas will create 4 new columns in the data frame, each containing the extracted date components, and this is especially helpful for analyzing patterns such as finding out which month have the highest sales or identifying specific weekdays that are the busiest. For example, if you are working with order data, you can see trends like whether weekends perform better than weekdays, like this. With Pandas, extracting and working with date components is simple and efficient. And .dt.year extract the year. Likewise, dt.month extract the month. Likewise, other codes work. Next, let's calculate the difference between two dates. For example, we can calculate how many days have passed since the order date. So I am going to calculate difference between two dates, like today's date or something else, and the order date. So df day since order, it's a new column, and equal pd dot timestamp. Here you can use any specific date, and minus df order date. So I'm going to calculate the overall difference into days. You can calculate into months or whatever days is more suitable. So dt dot days, and here we calculate the difference between a specific date and the order date. The result is stored in a new column called day since order, and sometimes you may have minus values. That means it's a future order date. So if the date order date is in future, you will get the days in minus. So you can mark those days like future orders. So like you can create a new column and mark them as using a condition, and create a new column like future orders. Here I have created a condition like df future order equal df day since less than 0. It will make as a boolean data type, which is we are using condition, like if the date since order less than 0, it's 2, and if it is greater than 0, false. Likewise you can find future orders. Also you can calculate hours, minute and second also from your date component. So you can use this code df hour equal df order date dot dt dot hours and dt dot minutes and dt dot second. These will extract hour, minute and second from your data frame. Today we learned how to work with date and time in Pandas, from converting to Datetime, extracting components and calculating date differences. These are must-know skills for anyone working with time-based data. If you found this tutorial helpful, please give it a like, share it with your friends and subscribe to Learn with Mafaza for more Python tutorials. Let me know your thoughts or questions in the comments below. See you in the next video.